All right, it's 10 a.m. We're going to go ahead and get started. Welcome to the second week of Advanced Kentucky's online AP content review sessions for AP Statistics. My name is Aaron Timmons. I'm the Mathematics Content Director for Advanced Kentucky. I'm joined by a co-host, Dr. Sherry McGuffin, who's our STEM coordinator, and our presenter for today, Miss Reva Slone from Johnson Central High School. She'll introduce herself later, but we are very lucky to have her. She will be very good for today's session on inference for proportions. So before we get started, just a couple housekeeping procedures here. So we are very excited to have all of you with us. We have designed these sessions for our Kentucky students and teachers to support them during this time, but we certainly recognize the fact that these will be useful to any teacher, educator, student anywhere in the world. So we just ask that you participate appropriately. If you are causing a disruption to the session, you will be removed. All of our contact information can be found here, our Twitter, Facebook handles for myself and Dr. McGuffin. A couple other procedures here. Our microphones will be muted the entire time, and your videos are going to be turned off. We ask that you leave those off for the duration of the session. To utilize some engagement here, we really want you to use that chat feature in the bottom right-hand corner. Please make sure you're using that. If you have questions for Dr. McGuffin, Ms. Sloan, or myself, feel free to chat us directly, or you can post questions to the entire group. Please make sure I understand that there are teachers and students in here. Teachers, if you have questions, ask away. I know that Trevor Packer did his presentation last night, so if you have questions related to the exam format for this year, feel free to ask and we will get you an answer. If you cannot hear what I'm saying right now, please check the chat box. I don't really know how you're going to understand that, but make sure you click join audio so that you can hear what's going on. If you have a friend that's in here that can't hear, pass that along. Hopefully you've checked out kyap2020.com by now. This is the site where you can find all future events for our content review sessions, as well as resources for both teachers and students. Past recordings will all be posted to this website as well if you want to watch these at a later time. So before we begin, I'm going to pause the recording here just for a couple minutes. I'd really like you to take a second, open up a different browser and go to this bit.ly link to sign in. It's a very quick 4-question Google form. But in the meantime, I'm going to give you some time to do that. Make sure you've got those handouts pulled up in front of you from the beginning slide. I'm going to hit record. I've got a very corny statistics song to share with you during this time as well. I think we're going to see if this works. All right, so hopefully you've had a few minutes to sign in. Make sure you've got the handouts in front of you. We are going to resume today. I'm going to introduce our presenter for you. It's Miss Reva Slone from Johnson Central High School. She will tell you a little bit about herself and her AP exam experience. So without further ado, Miss Slone, take it away.
Hi, everybody. I'm happy to be with you today. I've been teaching AP statistics for over a decade now. Makes me feel kind of old. And I've been a reader for the last 5 years, and I'm excited to be here with you today to talk about inference for categorical data. So let's get started. I've put together a slide to go along with the handouts that I gave you. And I'm going to turn off my own video just because it's a little distracting. And we're going to talk about inference for categorical data today, and that's proportions. Let's see, hang on one second. My slideshow is not started apparently. Oh, yes, it is. Okay. You guys seeing that okay now?
We're good.
All right, great. So thanks for joining today. I wanted us to get to know each other, and I've already told you a little bit about myself. So those of you who are joining, if you don't mind to sort of just drop in the chat your name, where you're joining from, and what your role is. Are you a teacher, a student? Maybe you're an administrator? Please tell us a little bit about yourself. Hi, Monique. think I actually saw a few students on here I know, not from my own classes, but from some surrounding communities. Hello to you all. Okay, you guys can keep that coming. I see we have a very wide representation. So first of all, I wanted to share just a little about the unit requirements from AP Central, from the College Board. This is just an overview of what's required for proportions. Of course, we can see constructing a confidence interval, justifying a claim based on a confidence interval, setting up a test for a population proportion, interpreting p-values, making a conclusion about a test. We also have types of errors, confidence intervals for the difference in two proportions, justifying a claim based upon that confidence interval, and then of course, also we have the test for the difference in two population proportions, carrying out that test and making conclusions. Some facts we know right now about this year's exam: it is going to be May 22nd. It consists of two multi-part free response questions. One's going to be 25 minutes and one 15 minutes in length. We expect when we say multi-part that there won't just be multi-parts like A, B, C, D, but also that these FRQs will combine topics from different units. I did not get to be on Trevor's talk last night, but I know Aaron was sharing with me that he had said you should not be discouraged if you don't get time to finish all that, that they are going to be intentionally long. Of course, when we're assessing a whole course, with just 2 questions, we should expect that those questions will be long. A calculator won't be required. So this is interesting, and it has us doing a lot of speculation about what they might ask us to do, since these are going to be questions you could answer without a calculator, with minimal pen and pencil based calculations. And of course, then this is unique also. You can use notes, not someone else's brain, but you can use notes. And so I would encourage you for each unit to maybe put together a 1-page reminder of the main ideas that your teacher has talked with you about. Maybe you've created foldables, or think about test review for each exam that you had, and have those ready and on hand.
Reva?
Yes.
I'll go ahead. They did make a very big, they took time to discuss the security measures they were putting in to prevent students from cheating. I know there's been a lot of concerns. They were very secretive about all of the measures they put into place, but I would not even test it, because they have plenty of interesting creative ways, they said, of making sure students are submitting authentic work. They said they've already even caught a student in AP Physics that was planning to cheat. So they're already be on the lookout.
Okay, I know also it's very unique this year. They're planning to send responses back to classroom teachers, and I assume they are inviting classroom teachers to help make sure that their students are not copying, and that everyone's doing their own work. So the first thing I wanted to do is take a look at a few free response questions with you today, and we may not look at all the parts of the questions, but we're going to look at what you might expect to encounter. So this is an older question from 2007, number 1. And I'm going to pause and give you just a minute to read the stem of the question, what's above those dot plots. Could you just read that part? So we can see that this question deals with discoloration ratings for 2 groups of strawberries. We have a treatment group and a control group. And as we look at the parts of this question, part A talks about the standard deviation, and they want us to explain how this value summarizes variability. Now that's not really connected to what we're doing today, so we're going to skip over that part. Part B says, based on the dot plots, comment on the effectiveness of the preservative in lowering the amounts of discoloration in strawberries. So maybe you could drop some things in the chat about what we would expect to see. If the preservative was effective, what would we expect to see in the dot plot? Maybe you could even just comment on, does it appear to be effective based upon the dot plots that we have here? Well, I don't see any comments coming through. Oh, there they come. Lower discoloration for the treatment group. So how would we measure lower discoloration? What would we be interested in? Center. Someone said the center. We noticed that the center for the treatment group is lower than the center for the control group. That might be something important. The mean discoloration, or maybe the median, is lower. Okay, so again, that's part of the question that we're not really interested in with what we're talking about today, but all those are good comments and good things to note and to point out. And so yes, you guys are all talking about features of the distribution we would want to look at. When we look at part C, this is the meat of what we're talking about today. Researchers at the university decided to calculate a 95% confidence interval for the difference in mean discoloration rating between strawberries that were not treated with the preservative and those that were treated with preservative. The confidence interval they obtained is given, 0.16 to 2.72. We're asked to assume that conditions necessary for the T confidence interval are met. Based on this interval, comment if there would be a difference in the population mean. Of course, we're talking about proportions, and this question is about means, but we still use the same type of reasoning. So I wanted you to see this question. What type of answer do you think the College Board would be looking for? What would they want students to comment on as far as this interval is concerned? This is a great example of using a confidence interval, albeit for means and not proportions. A great opportunity to use a confidence interval to test some type of a claim and to make a decision. So what should we focus on to determine if it's effective or not? We're looking at the difference in mean discoloration. Is there a difference or not? Great, I see those answers starting to roll in, and all of you are focused on the right piece of information. 0 isn't in the confidence interval, so it's plausible. We believe that there could be a difference. Let's look at the scoring for this question, and we're only going to focus on part C. I believe I have the model solution. So since 0 is not contained in the 95% confidence interval, we can conclude there is a significant difference between the mean for the two groups. Notice they state an alpha level here. We think there would be a difference. And in scoring for this question, they looked for a few things. We had to indicate that 0 is not included in the confidence interval, so there is a difference, and you had to state a conclusion in the context of the experiment. Okay, so that's this last sentence in the solution. We think there would be a difference in the population mean discoloration ratings. There was a comment, a note that I did not add, that you did not have to comment about this alpha level as the model solution does, but if you did, you had to use a correct alpha level. So here's another question. This one is about proportions, which is our topic for today. From 2010, number 3. Again, I tried to pull questions for you that are doable without a calculator. So take a minute and look at part A of this question. I think I did put a couple of questions here about what parts of the question are accessible without a calculator. So go ahead and read the question and answer that. Which parts could we do without a calculator? So could we answer part A without a calculator? Make sure you're responding in the chat when I'm throwing questions out there. It helps me know you're awake and paying attention. Yes, we could answer part A without a calculator. It's important to point out that part A asks us to interpret the 95% confidence level, not a confidence interval. And then part B, what about that? A National Pet Products Association claimed that 39% of all American households owned at least one dog. Does the Humane Society's interval, which is shared between parts A and B, provide evidence that the proportion of dog owners in this county is different from the claimed national proportion? Could we answer that without a calculator? Looks like those calculations are simple enough to be done by hand. Surely we could add or subtract 0.119 with 0.417. So let's take a look at the responses. For part A, the 95% confidence level means that if one were to repeatedly take random samples of the same size from the population and construct a 95% confidence interval from each sample, then in the long run, 95% of those intervals would succeed in capturing the actual value of the population proportion of households in the county that owned at least one dog. So this is the model solution. And notice scoring. In order to get an E, what do you have to do? There's 3 things here that they were focused on. You have to mention repeated sampling in the long run or using this method. You have to mention that 95% of those intervals would capture the population proportion. And you have to include context of the study in order to get an E on this part. For those of you who are students and who are joining us, if your teacher hasn't talked to you about scoring for AP exam free response questions, typically each part or certain sections are scored with an EPI rating, meaning essentially correct, partially correct, or incorrect. And so obviously we want to get an E on each portion for the highest score. For part 2, based on probability, the response must also state, this is a separate approach you could use. I try to encourage my students not to use the probability approach because it's almost never done correctly. If you try to base that interval or that level interpretation on a probability, you have to say there's a 95% probability that a randomly selected sample in the future would produce an interval that captures the actual value of the population proportion. Again, I would encourage you to stay away from this method. Look at method 1, and then notice the conditions for getting it partially correct. If you provide an interpretation of the confidence level, that includes 2 of those 3 components, or you provide a correct probability interpretation, but maybe you don't use the context. For part B, if we actually calculate the bounds for this interval, we'll see that it's 0.298 to 0.536, and this interval does include the value of 0.39 as a plausible value for the population proportion of households in the county that own at least one dog. So notice in response to that question, we want to say no. It said, is there support? Or let's see, I don't know if I can go back to that question. I don't have it pulled up in front of me. Give me just 1 second. I want to look at that actual question to reread that, see how the wording was. So I'm over in my documents. I know you're not seeing it, but give me just 1 second. So the wording of the question says, does the Humane Society's interval estimate provide evidence that the proportion of dog owners in the county is different? And so since that 39% is in the interval, no, there's not evidence of a difference. If they ask a yes or no question, be sure you clearly and unequivocally say yes or no. So as we look at scoring for this question to get an E, you have to correctly state that the 39% or 0.39, the claimed value, is in the interval, and that the interval does not provide evidence that the proportion of dog owners in the county is different than the claimed national proportion. You can see to get a P, there are a couple of different things that you can do, but we're going to go on to the next slide in the interest of time. Part C, this is just I wanted you to see how you would set this calculation up and look at sample size, but that's not something we're going to focus on because it's not likely to come up on this year's exam. Now we know that there are no multiple choice questions on the exam this year, so you may be wondering why I decided to include multiple choice. A lot of the multiple choice questions that are written are doable without a calculator. These are things that could easily be flipped from a multiple choice context to a written context. So part of what you should note as we move through the multiple choice is the wording on the correct solutions. What is it that we're focused on, and what should you communicate if you're expected to write a response to a question like this? So if Aaron will go ahead and put up a poll for this question. I'm going to give you guys some time to respond. Not sure exactly how many students we have out of these 30 attendees, but we'll give you a minute or two to respond here.
And if you're a teacher, you are welcome to respond as well.
Absolutely. So I'll give it about 15 more seconds on this question. Shouldn't take us very long.
And your responses are anonymous, so feel free to be right or wrong. We're okay here, so.
Okay, so we're going to go ahead and end polling. And so here are the results. Let's see what the actual answer is. D, very well. So most of you got that correct. And so this is just a question about margin of error and what that margin of error means. Are there any questions about margin of error? The majority of you got it correct. The margin of error, remember when we build a confidence interval, we start with that sample population proportion, and then we add or subtract some margin of error. So the difference between the sample percentage or the sample proportion and the population percentage is likely to be within that margin of error, 2%. So we're going to go on to the next question. And we're going to relaunch the poll. Take about 1 to 2 minutes to respond to this question. So we're going to go ahead and end polling on this question and take a look at those results. And so the majority of us chose B, and B is the correct answer. And so what is it about this question that we want to notice? Well, there's a few things that are important to notice. First of all, if we are required to write hypotheses, notice that each hypothesis, the null and the alternative, they're about the true population proportion P, so that's important. I tell my students I would throw out A and E automatically because almost always in AP statistics, we write the null as P equals or mu equals, it's always an equal to. So I would eliminate A and E right off the bat, looking at B, C, and D. And then what is it about this question that causes us to choose greater than? We have this statement that some customers have complained the elastic bands are breaking more frequently. So they believe that it's greater than 3%. And so we're going to go ahead to the next question. If you do have questions at any time, if you need further clarification on any of these questions, then you can go ahead and drop that in the chat. Again, thinking about as you move through these, what we would write, not just how we would choose the correct answer, but think about how this models what you should write if you're asked to identify hypotheses for a hypothesis test, which is very likely. Now, I did provide a hint for this question. This is a question that would not be possible if we did not have calculators, but I've provided a hint over here about the p-value. So go ahead and answer this question. We will relaunch the poll. Maybe for those of you who are wanting to respond, if you haven't noticed and the poll is popping up in front of that question, you can shift that poll around and move it out of your way. Minimize it till you're ready to respond. Okay, so let's go ahead and end the polling. So the majority of us have chosen A. And so let's think about what would we want to consider if we're making a decision about a hypothesis test. We always compare the p-value to the alpha level. And so here we call that alpha level a significance level. Those words are interchangeable, alpha level, significance level. And they've stated a significance level of 5%. And so since our p-value is less than our alpha level, less than our significance level, we want to reject. We always say reject or fail to reject the null. We know that we never make an acceptance of the null, so always reject or fail to reject. And in this case, we should be rejecting. The correct response is A. I wanted to look at the biggest distractor. It was C. Okay, so probably just confusion. It says since the p-value, I'm reading C, is less than the significance level, the null hypothesis should not be rejected, and that's just a little bit of confusion. Remember, if the p-value is less than our significance level, we would reject. Any other questions, comments on this question? Okay, so we're going to go ahead to the next question. Feel free to put questions in the chat if there's something you're interested in. Something I didn't address. We're going to go ahead and relaunch the poll here. and give you some time to think about this question. Give it just a few more seconds here, maybe about 15 more seconds. Polling is kind of slowed down just a little. So here are our results. I think this is the first time more of us have chosen an incorrect answer than a correct answer. So let's talk a little bit about this question before I give you the answer. If I think about a confidence interval and I'm comparing widths for an interval based upon a small sample of 100 men compared with a larger sample of 900 men, what do I know about those widths, just in general, before I get into specifics about 9 times or 3 times or the same width? What do we know about smaller samples compared with larger samples? Feel free to drop some comments in the chat. The smaller sample has a larger width. Anybody else? How about agree or disagree? Do we agree or disagree with this statement? Nobody wants to say exactly the same thing, but pop in agree or disagree. I see some agreement. Sure. Smaller samples are more variable. So first of all, I know the smaller sample should be wider. How does that help me with this question? If I know the smaller sample should be wider, then I can eliminate choices C through E, okay? Because C says the same width, and then D and E say that that smaller sample of 100 men is going to be more narrow, 1/3 or 1/9 the width. And so the correct response, there's the actual results from our poll. Sorry about that, I hadn't shared those with you guys. The actual solution is B. It's about 3 times the width. Well, why is this smaller sample 3 times the width if I've multiplied my sample by 9? If we think about where the width of the confidence interval comes from, it comes from that Z star times the square root of P hat 1 minus P hat over N. Okay, it comes from our margin of error. And so what we can see here, what they've tried to display in this solution, and I don't love the way this is written, is that in the denominator, okay, 100 is equivalent to 900 over 9. Well, if I think about taking the square root of that, what would happen? Okay, I would have a 1/3, but then I would divide that and end up with 3 times as large. So just always know that there's sort of that inverse relationship. It's going to be the square root of whatever our multiplier was. So we multiplied by 9, and the interval was 3 times as wide because the square root of 9 is 3. I would have written the solution just a little bit different than that. But okay, so we're going to relaunch the poll and have you take a look at this question. We may not get through all the questions. We'll see. We'll stop at about 10 till. And let you ask questions. Okay, I'm going to go ahead and end polling on this question and share the results with you. And then we'll talk about some important considerations. The correct answer here is B. Why did I share this question with you? Well, I think it's likely that they could ask us to set up the calculation for a confidence interval, or they might ask us to set up a calculation for a hypothesis test, even if we don't perform it. I also think there's a good chance they'll feed us some numbers like some of the previous examples have done. One of the big things that we need to think about here is when we're looking at that sampling error, do we pull or do we not pull? And so it's important to remember for two proportions, if we're doing a hypothesis test, we make the assumption that there's no difference in the two population proportions. And so if it's a hypothesis test, then we would pull the data since we assume that they come from the same population or that there's no difference in the proportions. Once we move to a confidence interval, we do not pull because we now believe there is a difference and we're trying to estimate the size of that difference. And so the correct choice is B. One of the big differences in all of these is that value of Z star, our critical value, and most of us recognize from 95% confidence the 1.96, and so even without a calculator, we should know this one should be slightly larger. Okay, oops, I don't know what happened on that slide. I must have forgotten to animate. We'll just go ahead and skip that one. And let's take a look at this question. We'll relaunch our poll. Notice this question is talking about the validity of a procedure. And in order to think about the validity of a procedure, we want to think about the conditions that we should check. So what are the conditions for a confidence interval or a hypothesis test for proportions? Drop some of those in the chat. What are the conditions we should be thinking about and checking? Random, we check randomization. We want to be careful about whether we had random selection or random assignment. Was this an experiment where we randomly assign people to treatments, or was this a random sample? So we do see random selection here. What else should we be interested in? A couple of these choices talk about sample size. How do we check that the sample is large enough for proportions? So I see somebody else has dropped in the 10% condition and large counts. So 10% condition, that's important. So there were 37 employees. Assuming they have at least 370 employees, we have less than 10%. What about that large counts? Seems to be maybe what we need to focus on here. All right, so N times P hat and N times Q hat, or for those of you who may use the 1 minus P, they should both be at least 10. And if we go ahead and end the polling here and share results, I think most of you did a good job of zeroing in on the right thing here. So C is the correct choice. Notice they tried to mislead us a little bit with A. That would be a condition for means, not for proportions. And it looks like most of us chose the right solution, so we'll just go ahead to the next question here. I don't think there's a lot to talk about there. And we'll relaunch the poll here. So we've seen some similar questions here, but there's this question of the significance level that's pulled in. Okay, so I'll give it about 15 more seconds and then I'll end this poll. And here are our results. The majority of us did choose the correct answer. And so just a quick comment, if we have a 95% confidence interval, we're looking at that central 95% of the data. To determine the appropriate alpha level, we would have to think about the two tails together. And so the two tails together would make up the other 5% of the data. Sometimes we do get questions about if we did a hypothesis test, what would happen, and we would need to focus on whether we had two tails or one tail for that. So we'll stop sharing these results. Not sure how many more multiple choice questions we have, but we'll go ahead and relaunch the poll for this one. We'll give it about 30 more seconds. I think we've kind of reached the capacity for where we've been on the number of responses. So let's end the polling and go ahead and share your results. And sure, D is the correct solution. Again, the majority of us chose that. There were a few of us who thought that A was correct. So if we compare the two, what are we looking at? Well, we had a random sample of 432 voters. Revealed that 100 are in favor of a certain bond issue. So a couple of things we noticed about A. First of all, we should not have the number here in favor for 100, but we should have the proportion. And so we had 100 out of 432, which would be the 0.231. So we should be looking at D and E. Also, another problem with A, we use the conservative 0.5 and 0.5 for P and 1 minus P, when we actually have the 0.231 as our population or as our sample proportion, and we should be looking at that and then 1 minus P in the standard error setup. We do have, I did say I was going to stop at 10 till, but I think we just have one more question and a little follow-up that goes with it. This is a very important question. We haven't looked at type of error yet. So go ahead and take a look at this question and see if you can identify a type 2 error. I see a question in the chat. How would we have found the plus or minus 1.96 without using the inverse norm setting on a calculator? There is a way to use the table to do that. And I can talk to you about that in just a couple of minutes after this question. But also that's kind of one of the more common ones. We know that 95% of the data is within about 2 standard deviations of the mean, and that 1.96 is the closest. Oh, I should be relaunching the poll here. Sorry about that. Maybe you've already decided your answer. Just a few more seconds for you guys to respond on this one. If you've forgotten, we're asking about type 2 error here. So the 2 types of errors, a type 1 error means we reject the null hypothesis when it was true. And the type 2 error means we fail to reject the null hypothesis when it's false. So in context, sometimes that can look a little confusing. So we'll end the poll and we'll take a look, we'll share your results and take a look at the solution. And so we would fail to reject when it's false. So it's false that the patient does not have flu. The patient does in fact have the flu, but we fail to reject that believing that they do not have the flu. So part B, failing to diagnose the flu virus in a patient who has the flu virus would be correct. And most of you got that. I did add a follow-up question here. Would any of the choices describe a type 1 error? And I don't think we have a poll for that. Actually, we could just relaunch this poll. So if we were looking for a type 1 error, what would a type 1 error be in context? I'll give it about 10 more seconds. And so we'll go ahead and end the polling. Most of you chose C, and in fact, that is correct, C. I'm going to go ahead and stop. Actually, I won't stop sharing here. I'm just going to click through a few slides, so bear with me for just a second. Well, this would be a good place to have commented. I'll get to that in just a second. All right, so at the end of your handout and also here in the PowerPoint, I added just some quick reminders for a complete response. For confidence intervals, we have to identify population parameters. We have to state and verify conditions, complete calculations, and then write a conclusion. And we don't have a whole lot of time to talk about those. Aaron had asked me to clarify something earlier, and I want to do that. So for hypothesis tests, here's just some quick reminders of things that you may want to look over or talk about with your teachers. And one of the things that we wanted to talk about is the population parameters must be defined in the context of the problem. What do we mean by that? Well, I'm going to stop sharing that slide for just a second. I'm going to share something else with you if you'll give me just a moment. Okay, let's see here. Let's see, I want to share a different screen with you. Here we go. All right, so this is the handout that you guys actually have. You should be seeing that now. And one of the things that Aaron had asked me to clarify could come up in this question that we talked about earlier. So let's look at number 4. And we wanted to talk about the importance of defining the population parameter in context here. So whenever you write the null and the alternative hypotheses for a hypothesis test, it's not enough just to write P equals 0.03 and P is greater than 0.03. You have to define what P is. So we would want to say that where P is the true proportion of, what were we looking at here, of elastic bands that break when stretched to a length of up to 8 inches. That is very important. Before this past year's test, we kind of let students get away, especially if there were 2 proportions, of using subscripts to identify. If we're looking at males and females, for example, P sub M, P sub F. I was looking to see if I had an example in here of that. I don't think I do. But if we were looking at 2 proportions, we would use subscripts and we would allow that to be enough. But with last year's test, we moved toward requiring students to clearly define those parameters. So Aaron, I hope that answers the question. And I'm going to go ahead and turn it back over to you.
All right, that was a great explanation. We have about 3 minutes. If there's any other questions you have for Reva, please put those in the chat box. I'm going to go ahead and share my screen, just do some wrap up here. All right, so again, thanks to Reva, incredible job, very insightful. I think we all learned a tremendous amount here today. If you have any follow-up questions for Reva, or if you have questions specifically for myself or Dr. McGuffin, feel free to reach out to us, give us a follow, send us an email. Reva's email is there as well. She said she would welcome any questions that you all have afterwards. If you are a teacher and you would like the solution or the PowerPoint slides to today's presentation, shoot us an email and we will get those to you. The sign-in link, if you hadn't had the chance to sign in this morning, please go ahead and take the chance to do that, as well as handouts are available at that link, as well as the kyap2020.com website. Today's recording will be posted to that website here by the end of the day as well. Next week, same time, we are going to be joined by Mr. Adam Schrager from New Jersey, who will be covering Inference for Means with us. So that's Unit 7 in the CED for those of you that are following that from your course units at a glance. So Reva, Sherry, any other follow-up closing remarks for us before we sign off?
Thank you all for joining us.
And just one quick question, Aaron, and those AP Stat study sessions and the content review sessions will be running how long now? Through what day in May?
We're running through the month of April, and we have actually just added one more session on May 21st, which is the day before the AP exam. So those of you that want some last-minute review, join us then. That information can be found at kyap2020.com as well. Thanks, Sherry.
No problem.
All right, so with that, we will sign off. Reva, Sherry, if you can just hang on tight for a second afterwards, we'll do a quick debrief. But please join us here next week, and we look forward to seeing you then. See you later.